All right, good morning, everybody. Today we are going to do a schedule upload. So let's jump straight into it and continue from the last class. So in the last class, we ended off where we calculated gradient, midpoint, and length of line. Reminder, the length of a line is a number. The gradient of a line is also a number. And the midpoint of a line is a point which comprises of a x and a y coordinate. So just keep that in mind when you're calculating midpoint. Midpoints will be a coordinate 2, 7, whereas the length is going to be a number, as well as the gradient is going to be a number. So today we're going to dive into this concept of the equation of a line. The equation of a straight line. Now, I will emphasize this. Equation of a straight line requires some subject of the formula work or solving for a variable in a linear equation. So I will recommend that you go back into the previous videos, look for the one we solved linear equations, and you'll get a better understanding of how we're solving for the equation of a line moving forward. Now, I'm sure everybody knows that the equation of a line, well, most people probably know that the equation of a line is represented as y is equal to mx plus c. M and c are numbers, or we call them constants. X and y are we variables. And again, it's variables because they can vary in value. So if I have an equation that looks like y is equal to a number times x plus another number, we can say this is the equation of a straight line. M represents something and C represents something if and only if the formula or the equation looks exactly like this. So for example, if I have y is equal to 2x plus 4, it's clear to me that this takes the form y is a number multiplied by x plus another number. The first number, this here, if I do a side-by-side comparison, this fella here is looking like my m. And m is equal to the gradient. All right. M represents the gradient, and this fella here, he looking like C, which will represent the y-intercept. Now, we know that the gradient has a formula to calculate, and the y-intercept is just where the line cuts the y-axis. So let me just draw it now and see what happens. Now, every equation that has a x and a y in it possibly could be drawn on a graph. So let me check and see. We had y is equal to 2x plus 4. So y is equal to 2x plus 4. Shucks, I have pi, sorry. Y is 2x plus 4. I get a straight line. Now, based on this information, the gradient is 2. Based on the previous classes, when we talk about gradients, a positive gradient will definitely go in this particular direction. Plus 4 is the y-intercept, or it is where the graph cuts the y-axis, and it's 4. So, seeing some interesting things happening here. So, let me do a little alteration. A little different thing. If I have 2y is equal to 6x plus 10, Now here, I'll ask yourself, what is the gradient? It looks like the gradient is 6. But, big but, this equation, it's not looking like y is mx plus c. It's looking like 2y is mx plus c. I would like to get y by himself before I can look at the equation and get an answer. I have to look at the equation, and the equation has to be y alone is equal to whatever number times x alone plus whatever number. So in order to get y by himself, I need to get rid of the 2. If you go back into the video where we solve a linear equation, you will understand I have to divide by 2 through the entire equation, or divide by 2 on both sides. For these cases, we'll divide by 2 through the entire equation. So everything is divided by 2. So if I divide by 2, I get 2y over 2 is equal to 6x over 2 plus 10 over 2. 2 cancel with the 2, you go into u 3 times, you go into u 5 times. And I get y is equal to 3x plus 5. Let me draw 6x, the first equation, 2y is 6x plus 10. And let me see what happens, right? Now, both of these equations here, 2y is 6x plus 10 and y is 3x plus 5, they have the same weight. It's just I write it different. That's all. Right? It's the same equation, but I just write it a little different. So if I draw 2y is 6x plus 10, 2y is equal to 6x plus 10. I will put this one as the green line, right? Now, I'm going back here. If I work with the first equation and I fall under the false illusion that 6 is the gradient and 10 is the y-intercept, that's not the case, because I can calculate the gradient here. The gradient of the green line is 3. But again, the false illusion tells me the gradient is 6, because I do not have y as mx plus c. I have 2y as mx plus c. So when we do little alterations and I get the equation looking like a certain form, which is y is mx plus c, I can read off the gradient, which is 3. And based on the green line, the gradient is 3. And the y-intercept is 5. The y-intercept is 5. That is where it cuts the y-axis. So the equation of a line, as long as I have a x and a y on the numerators, I'm good to go. Once I can bring it in the form y is mx plus c, I'm good to go. Let me do another one here. 6x plus 2y is equal to 11. Now, again, homeboy not looking like y is mx plus c. And again, I will advise you guys, go into the solving linear equations remedial class and watch that video. You all will understand how I'm doing what I'm doing here. I have to make y the subject of the formula, or I have to solve for y. In order to do this, I need to do some rearranging. I'll get 2y is equal to 11 minus 6x. I'll divide by 2 throughout. I'll get 2y over 2 is 11 over 2 minus 6x over 2. You cancel with you. I'm not going to work with no decimals in coordinate geometry, especially when it comes to equation of a line. Big important note. Don't work with decimals. The only thing you'll work with decimals in is your length. That's the only thing. So 6 is going to do 3. So I end up with y is 11 over 2, take away 3x. Now, I want to have y is equal to something by x plus something. So I'll put the x's directly after the equal sign. Note, I'm not jumping no equal sign, so I'm not changing no sign. So I'll get y is equal to minus 3x, I didn't jump over equal sign, plus 11 over 2. If I draw this line, either this equation or this equation I am going to yield the same exact graph. The only benefit of having the equation written in this form here is I can watch it and say, yo, the gradient is minus 3. Yo, the y-intercept is 11 over 2. That's the only benefit. And it's a big, big benefit. If I draw it, 6x plus 2y is 11. 6x plus 2y is equal to 11. Brother man, based on my equation down here, the gradient is minus 3. Let me check it out. The gradient of this line here is indeed negative 3. And the y-intercept is indeed 5.5 or 11 over 2. So based on my equation, that will give me information when I look at it. The gradient is minus 3 and the y-intercept is 11 over 2. Now that we learned about transposing an equation or making the equation look like the equation of a straight line where I can read information, in each of these cases, there are statements I would like you all to write. In each of the cases, you will say, brother man is of the form y is equal to mx plus c, where m is the gradient, and you can abbreviate gradient as grad, which is 3, and c is the y-intercept, which is equal to 5. I'll do the same thing here. Is of the form, and I like to write them directly under each other so it's easy for me to see. Y is equal to mx plus c, where m is the gradient, and in this case the gradient is minus 3, and c was my y-intercept, which is equal to 11 over 2. And again, I stress, please, please, please do not use decimals when you're working with the equation of a line. Now, you're probably wondering, well, what is x? What is y? So I'm going to put a definition for a straight line here. A straight line, or the equation of a straight line, the equation of a straight line will satisfy all points on the line. What does that mean? What does that mean? I'll work with y is 2x plus 4 first to illustrate. For example, y is equal to 2x plus 4. Now, we just now established this line could be drawn on a graph. And luckily, we have the graph. The graph for y is equal to 2x plus 4 is as shown in the diagram. Now, based on the graph, and I recommend if you're lost when I'm doing this, go back to the first video on coordinate geometry. Based on the graph, when x is minus 1, I either have to go up or go down to get a point on the line. If I go down, I never intersect the line at all. Meaning I physically take my eyes and I keep watching down. I'll never intersect it. However, if I take my eyes and I watch up and I go up, I meet the line. This is how we will determine a point on a line or a point on a graph. Either we go up or down from any x value, we go up or down, where we reach the line, go across, and that's my corresponding y value. Now, for all intents and purposes, brother man, you have an infinite number of values you can read off. But we're going to read off values that are nice to work with. Whole number. So when x is minus 1, I go up, across, I get y is 2. So this point here is -1, comma 2. For our next point, when x is 0, ask yourself, do I have to go up or do I have to go down? You have to go up to meet the graph. When I go up, 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 I get y is 4. So 0, 4 is going to be the next point. 0, 4. Now I can keep doing this over and over and over again for an infinite number of points on my x-axis. So if I say when y is equal to when x is equal to -3, down, 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 down. This time I have to go down, across, 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 across. Y is equal to -2. So I put the point, C is the point, -3, -2. I can do it for a number of points, any number of points. So let me just put one arbitrary point D on the line. Based on the graph, I can read off the point on the line. But it's difficult for me on the graph to actually see that this x coordinate is negative 1.719. Honestly, it's difficult for me to see it. There's no way I can 100% accurately read this off if I have a graph in front of me and I'm reading it. Based on the app is going to give me precise points, precise measurements. But realistically, on a graph, I cannot read off this point. And we'll come to that in a little bit. So you can see that for every single point on the line, I can read off the x coordinate and the y coordinate. For every point on the line, it doesn't matter where I go, there will always be an x and a y. Now, by all means, all of these points are on the line. A, B, C, and D are points on the line. Realistically, I cannot do this on a piece of graph paper. I cannot do this. Right? I cannot. So suppose I want to know, well, brother man, when x is 300, what is y? On the app, we could read it off. Yes, on the app, we could read it off. But there's no way we can accurately draw this on a graph paper. This is where the equation of a line comes into play. Now, based on the app, when x is 300, ask yourself, am I have to go up or do I have to go down? Ask yourself, take a few seconds, ask yourself. You have to go up. We go up, 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 up until we meet the graph. Across, 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 across. Brother man, it's looking to me when x is 300, y is 600. That is what it's looking like. Alright, so let me just. Okay, they're looking so no more. Right? It looks so, right? But that is not the case. When x is 300, I will try my best. Trying my best. This could be a good exercise too. When x is 300, y looking like 604-ish, somewhere around there, right? It is looking somewhere around there. And this is the beauty of the equation of a straight line. We will come back to that point just now, right? Let me deal with these 4 points first. So, based on the graph, when x is equal to, we'll go back here, when x is equal to 0, y is 4 for point B. When x is 0, I got y is equal to 4. When x was -1, y was equal to 2. -1, y was equal to 2. when x was minus 4, y was equal to minus. I could have taken any points, right? Any points at all. But this is based on the graph. Let's try to use the equation now. Based on the equation, when x is equal to 0, based on the equation, I'm saying x is 0. So I will put x is 0. Y is equal to 2x, which is 0, plus 4. I got y is equal to 4. So based on the graph, when x is 0, y is 4. Based on the equation, when x is 0, y is 4. Alright? Based on the equation, when x is minus 1, y is equal to 2 into minus 1 plus 4. Y is equal to minus 2 plus 4, which is 2. So again, based on the graph, when x is minus 1, y is 2. Based on the equation, when x is minus 1, y is 2. We'll do the last one and some more. When x is minus 4, y is 2 into minus 4 plus 4. That could be minus 8 plus 4, which is indeed minus 4. Let me do one that we didn't read off as yet. You can pick any x value. But again, we could pick nice x values, right? When x is equal to, let me say, 7. When x is 7, y is equal to 2 multiplied by 7 plus 4. 7 to the 14 plus 4. Y is 18. So based on the equation, when x is 7, y is 18. Based on the graph, when x is 7, make sure I have 7 there. When x is 7, I need to go up or down. Ask yourself. We had to go up. We're going up, 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 until we meet the graph. Across. Y is 18. So I can use the equation of a line to calculate literally any point on the line. And this is what x and y represent. X in the equation will represent any x coordinate on the line, and I can calculate the corresponding y coordinate on the line. So we have a method to calculate gradient. We'll come to that just now. For now, I want you all to get comfortable reading off the gradient from an equation and potentially calculating points on the line. So let me try a couple examples again. And I will leave these examples for you to try. So when you're watching the video, please give it a pause, work it out, play back the video, and see if you get the correct answer. 6x minus 4y is equal to 2. Pause the video. I'm going to work it out now. It is not of the form y is mx plus c. My aim is to read off the y-intercept and read off the gradient from the line. So I need to rearrange a little bit. So one of two things I can do. And I'll do both ways and show you all you get the same answer. I can move the 4y on the left, on the right, sorry, move the 2 on the left. So let's do that. I have 6x minus 2 is equal to 4y. Now, why will I do this? I'm doing this to have a positive number in front of y. In other lives, nobody really likes negative numbers. We like positive numbers more, especially if the positive number starts an equation. I want the number in front of y to be positive if I could be, right? If I can make it positive, I will make it positive. Now think about it. If I have pen is equal to mouse, it's the exact same thing as saying mouse is equal to pen. Exact same thing. If I have 6x minus 2 is equal to 4y, is the exact same thing as saying 4y is equal to 6x minus 2. So I'll write that down. 4y is equal to 6x minus 2. Now, I want y by itself. Brother man, I'll divide by 4 throughout. 4y over 4 is equal to 6x over 4 minus 2 over 4. The 4 cancels with the 4. I could simplify this. This becomes 3 over 2, and this becomes 1 over 2. Y is equal to 3x over 2 minus 1 over 2. Now, this is totally acceptable, and you all can make this part of your muscle memory. If I have 3x over 2, that's the exact same thing as saying 3 over 2x. Take away 1. And this is of the form y is equal to mx plus c, where m, way downstairs, m is the gradient, which is equal to 3 over 2, and c is my y-intercept, and be careful here, which is equal to minus 1 over 2. Just be a little careful here, right? So, I'm not going to make this any long, extensive video. I want you all to get very, very comfortable with rearranging an equation to make it look like a straight line in the form y is equal to mx plus c. The reason for this is it's easy for me to read off my gradient, and it's easy for me to read off my y-intercept. So I'm going to leave about 5 questions for you here, and you all have to do them for me. In the beginning of the next video, I will have the solutions ready, and you all will check it. All right? If you want, you can download GeoGebra, go and draw the lines, use the tools like I did, see where the y-intercept is, see what the gradient is to verify your answers. Okay? So please, please, please keep practicing these here, and I'm going to leave these for you all to do for next week. Now, I want you all to write your statements for each one. Please write your statements for each and every one of them. Bring them in the form y is mx plus c. So if I have 6x minus 2, y is equal to, I'm using 6x plenty, 7 minus 3x is equal to 4y. 20 plus y is equal to 2x. 25x minus a half y is equal to 3. I'm going to start incorporating a little bit of fractions in it now. Right? Nothing wrong with fractions, it's just a number. 4 over 3y plus 2 over 3x plus 4 is equal to 0. And number 5, 2 into x plus 3 minus 4 into y minus 6 is equal to 1. Right? So work with these 5. See if you can rearrange them. In the last one, you have to expand and then rearrange. And see if you can bring them in the form y is equal to mx plus c. And make sure you use proper fractions. Do not use decimals. Please do not use decimals. Work this out, and I will see you guys